Okay, so here's one of the last lessons we do in electrochem, and this one is cell stoich. So when we're looking at cell stoich, I hope to show an easy way of thinking about it, and it is just realizing we just need half reactions. You don't need a full redox reaction. So when you have a half reaction, we do still have electrons, and we'll be using this formula, which is moles of electrons equals your current times time divided by Faraday's constant. Really to look out for here is time must be in seconds. And for Faraday's constant, you don't need to memorize it because it is in your data booklet, but you don't have this formula, so that is going to be memorized if you're in Chem 30. So this first question, we have an electrolytic cell to plate copper onto a belt buckle, and we want to figure out the time it will take if we get 2.5 grams of copper from copper 2 nitrate solution with 2.5 amps as a current. And then the question, at what electrode should the belt buckle be attached? So anytime you are plating, the site to be plated is your cathode. So if you want your belt buckle to be plated, that must happen at your cathode. So now, with that said, if copper is the one that's being plated and it's coming from copper 2 nitrate, you can look up the half reaction for copper 2 positive to turn into copper solid. Now, this is in your data booklet. If you can't figure it out, you just have to take a look at page 7. Now, from here, what we have is mass of copper, right? 2.5 grams. So we can start with the mass of copper and multiply it by copper's molar mass, 63.55 grams per 1 mole. And that gets grams of copper to cancel. And now you're at moles of copper. And for every 1 mole of copper produced, we used 2 moles of electrons. So that is your mole ratio. So I'm going to multiply by 1 mole of copper in the denominator, sorry, this is moles, and 2 moles of copper in the numerator is what we have. 2 moles of electrons, sorry. So now that cancels and you're at moles of electrons, and you can plug that into your calculator and you should see the value 0.0786, and this keeps going, and that's moles of electrons. Now from here, because we want time, you can use the formula moles of electrons will equal I times T divided by F. And we are solving for T. We've now figured out moles of electrons. You were given amps, and we know Faraday's constant. So let's go ahead and plug that in. Again, this value is in my calculator because I don't want to round yet. Not times. This has to equal your amps, which is 2.5, times your time, divided by 9.65 times 10 to the power 4, and that's coulombs per moles of electrons. So to isolate T, we're going to multiply Faraday's constant to the other side and divide by 2.5. So let's go ahead and do that. Power of 4, and we want to divide that by 2.5. So for time, once you isolate it, I'm getting the value 3036.97, and again, that value can keep going, and it's in seconds. When I go to look at my answer given is in minutes, so to just make that conversion, I have to divide my seconds by 60, and to turn it into minutes, I would get 51 minutes, and that is what I wanted to see. So that's our first one. Let's look at another one where we're starting with the formula and have to calculate mass. So this one's asking, our next example, mass of chlorine produced when 200 amps flow through for 24 hours. And then it's also asking at which electrode is the chlorine produced. So because we're producing chlorine gas and it's coming from molten sodium chloride, if this broke apart, if we separated it into its ions, you have Na positive, it would just be in the liquid state, and you would have Cl negative. So we know that we're using chlorine ions to make chlorine gas. So again, that's the half reaction we want. So we can look at our data booklet, and our data booklet would show us 2 moles of chlorine ions will give you chlorine gas plus 2 electrons. So what we're going to start with here, because we have enough information to go straight to the formula, we can figure out moles of electrons and then use the mole ratio. So let's go ahead and do that. Moles of electrons will equal 200 amps times our time, 24.0 hours, but we'll have to multiply this by 3,600 seconds per hour so that our time can be in seconds. And this is all divided by Faraday's constant. Sorry, this should be coulombs per moles of electrons. So let's go ahead and plug that into our calculator. If you are doing this in all one step, just make sure you keep Faraday's constant in brackets in the denominator so that your calculator can read that properly. And then I just have to do that times 10 to the power of 4. I'm getting the value 179.06, and that number keeps going, and that's moles of electrons. Now, because it's asking about mass of chlorine gas, I want to multiply this by the mole ratio that turns moles of electrons into chlorine gas. So that would be 2 moles of electrons in the denominator with 1 mole of chlorine gas in the numerator. That gets moles of electrons to cancel, and then my last step is to get grams of 1 mole of chlorine. So going from there, I see my molar mass, but because it's the gas, I'll just need to make sure I multiply that value by 2. So I'd have 35.45. Again, I'm just going to show that I'm multiplying this by 2 so that I have 2 of them, and then I'll just finish off that calculation. So I'm multiplying by that mole ratio, and then by my molar mass. So I'm getting a pretty large number here, which is 6,347.9, and this would be grams. So going from grams to kilograms, I just want to divide by 1,000 and then round to keep 3 significant digits. So I get 3.65 kilograms as my answer, and then asking about which electrode it is going to be produced. Just looking at what you're starting with, you have a negative ion, and negative ions will lose electrons. So if you're losing electrons, you're undergoing oxidation, and oxidation happens at the anode. So chlorine gas will be produced at the anode. As always, I hope you found this helpful. If you did, please make sure to subscribe, and if there's any other video I can ever do for you, just let me know. Thank you for watching.